A geometric series is just slightly different. Again, in your formula packet, where the geometric explicit formula is, below it is the sum of a certain number of terms in a geometric sequence. Again, it's starting with the first term and not in the middle, so you're only ever going to be asked to find a sum of a geometric sequence from the first to a certain number, as opposed to like a middle chunk out of the sequence somewhere. I will just give you one formula. The two formulas are the same. There's just one I prefer to use. If you discover or want to try out the other one, it's really not that much of a difference. Okay, R, remember that R is your common ratio. So U sub 1 is your first term times your common ratio raised to the number of terms that you're adding, and then you minus 1 from that, and then you do R minus 1 and divide that out in the bottom, and that's how you find the sum of that series. Okay, example 6. Consider the partial sum for the first 20 terms of this series. We need to write the partial sum in sigma notation. So in order to do that, we need to know what the definition of this series is. So 3, 6, 12, 24. The common ratio is 2, and our first term is 3. So A sub 1 equals 3, R equals 2, A sub n equals our first term times our common ratio raised to the n minus 1. Just going back to your formula packet, remember that explicit formula is in there for you. All right, so to then turn that into sigma notation, we're talking about from the very first term to the 20th term, and then we need to put the definition in there. Okay, I am going to, so that's it for that. And then if we're going to find the sum, we're going to practice using our sum value in here, our sum calculations in here. Remember that we go to calculus and then 3 to get our sigma notation. So finding the sum, we've got n equals 1 all the way up to 20 of 3 times 2 to the n minus 1. I get my answer in scientific notation because it has that E6 at the end. What I did is I scrolled up and pressed enter to bring it down to the next line, and doing so will give it to you in non-scientific notation if it's small enough. Okay. So we could have also used our formula, S sub 20, come on, equals, and then it was our first term, which is 3, times our common ratio, which is 2, to the 20th minus 1, all over our common ratio, which is 2 again, minus 1. Calculating that all out, if you decided to calculate it that way or using your sum notation, that is 3,145,725. And that is your answer. Okay. Our last example for today. A ball has elasticity such that it bounces up 80% of its previous height. Find the total vertical distance traveled up and down by this ball when it is dropped from a height of 3 meters and after it bounces for the 10th time. Ignore friction and air resistance. So let's start making a series of this information, right? So first, the ball comes down from a height of 3 meters. And that's our first term. Plus, and then we need 80% of the previous height. So I'm going to do 0.8, which is 80%. times 3. Now realize it bounces up 80%, and because it specifically says here in the problem, it says find the total vertical distance traveled down and up. So we're talking about a ball going up, well, it originally comes down 3, and then it bounces up to 80%, but then it has to still come back down that 80% height. So not only are we going up that whatever 0.8 times 3 is, 2.4, is that what it is? So not only are we going up 2.4, we're then coming back down 2.4. So we actually have to multiply this guy by 2. So let's continue that pattern. So if we went up 2.4 and down 2.4, the next distance is going to be 2.4 times 0.8. So that's going to be 0.8 times 0.8 times 3 times 2. Oh, wait, not times 2. Well, yes, times 2, but in a different thought process. And then that guy's times 2. So the reason why I put times 2 on the outside is because I was originally calculating 0.8 of the height of going up and down, right? So instead of it being 2.4, I was calculating 0.8 of whatever 2.4 times 2 is, which is 4.8. So instead of doing this distance, I was calculating 0.8 of twice of that distance, which is not what I want to do. I want to calculate 0.8 of the distance that I went back up, and then take that distance and multiply it by 2 because I went up and then down of that distance. Okay. And then if I wanted to continue that pattern just one more time to see what's going on, it's going to be 0.8 times 0.8 times 0.8 times 3 times 2. And then we keep going with that pattern until the 10th ball. So that's only the first 4 terms. So I want you to realize that what we're multiplying every single time what we're newly multiplying every single time is 0.8. While yes, we're multiplying 2 every time as well, we're not re-multiplying by 2 in the idea of this sequence. 2 is just kind of always a part of it. So our common ratio is still 0.8, but our first term so your book wants to count your first term as 2.4, but I don't agree with that. I think your first term is 3. Hold on one second while I double check something. Okay, so I'm going to try and solve it differently than your book, and we're going to see if it works out. So my common ratio is 0.8, and my first term is 3. Actually, we're going to solve it kind of similar to what your book is doing. So the thing is here is that 3 is doesn't follow the pattern really of what we're doing from bounce to bounce, because it's only being counted once, whereas all of the other ones are being counted twice. So what we're going to do is we're going to count this as the beginning of our geometric sequence, and then we're going to add 3 at the end for our total height. So we're going to say that R is 0.8, but A sub 1 is not 3. A sub 1 is 2 times 2.4, which is, it's 0.8 times 3 times 2, which is 2.4 times 2, which is 4.8. Let me just double check that before I go down this rabbit hole. Okay. So A sub n is going to be A sub 1 times your R to the n minus 1. So that's going to be your definition of your sequence. We want to find the sum of all of those terms up to the 10th term. So we can use our sigma notation. So we're going to do 3 plus the sum of from n equals 1 to the 9th bounce, because if 3 is it says after, let me double check. It says after the 10th time it bounces. So 2.4 is the height after the first bounce. And then the subsequent bounces, the heights. So I'm sorry, I'm struggling on describing this. It makes sense in my head. So this is the height after the first bounce. This is the height after the second bounce, right? So it says after it bounces, that's the height. So after the 10th time it bounces, after it completes that 10th bounce, then we want to know how much it's gone up and then down. Well, notice that the height after the first bounce also coincides with our first term, A sub 1, which is 4.8. So if we want to know after the 10th bounce, we are calculating all the way up to 10 here. At first, I wanted to say 9 because we got rid of 3, but technically 3 happened before the first bounce. Okay. And then we'll do 4.8 times 0.8 to the n minus 1. You can use your formula that's in your formula packet, or you can use your calculator, which will calculate the sum for you, all the way from n equals 1 to the 10th bounce of 4.8 parentheses 0.8 to the n minus 1. And then I add 3. Womp womp. I get a different answer. Okay, so I spent quite a bit of time double checking work. And I kind of feel the same way as the child that's having a temper tantrum out in my hallway, that the textbook was wrong. So I tried all the calculations like the textbook told me to do them, and I still got different answers on my calculator. I tried it with using the sum as well as the formula, and I'm getting the same answer over and over and over that I got here. It's just different than the text, which is leading me to believe that the text is incorrect in this and that I am correct. Ta-da! That child is having a meltdown. Okay, so the answer here is 24.4 as the total height traveled up and down after 10 bounces, which is like significantly more distance than the initial drop of 3. Okay, I know these are really long. Again, I'm really sorry. You are done. You have all the information you need for your notes for today. I will have on the website additional practices for you to try because this was really rushed. It was a lot of information all at once. It's all based off of formulas that will be given to you or a calculator that can help you. So it's not really big conceptual wise. It's just a lot of different formulas. IXL practice that you can find on my website, not on Google Classroom. Use that as a way to double check that you've got it all down pat. Okay, good job today, guys.